In this video, I'll be doing Khan Academy's SAT Math Practice Unit 7 of Problem Solving and Data Analysis Medium. So this is the unit practice test and it has 10 questions, so let's get started. Wholesome Food Company asked all students on the baseball team at Ridgemont High School the question, "Do you like broccoli?" 15% answered yes. Based on this data, which of the following conclusions is valid? So let's read the answer choices. About 15% of all students at Ridgemont High like broccoli. We don't know that all students at this high school like broccoli because here it says they only asked all students on the baseball team. So A is wrong. B, exactly 15% of all students on the baseball team at Ridgemont High like broccoli. This seems pretty accurate. It seems valid right now, so we're going to keep B. C, 15% of the students on the baseball team at Riverside High, Ridgemont's main rival in baseball, like broccoli. We really do not know that at all. C is really random. We have no info about Riverside High, so C is wrong. And then D, 15% of the students on the baseball team at Ridgemont High like all vegetables. We do not know that. They just asked, do you like broccoli? And so the answer is B. We have a table here. Let's read the question. The table shows the percent compression of a coil spring in a mattress, which is measured when different amounts of force are applied. Okay. Which of the following best describes the relationship between the percent compression and the force? So we have a table here, and we can put it into the graphing calculator. Okay, so let's put into the graphing calculator with all the points that we have, or that we were given. So it seems like this percentage is kind of adding 3 each time, except for D's right here. 9, 11, 13, and 15, that's adding 2. Okay, so now that we put it in, we can zoom fit to see the graph. So it seems linear, so let's make a linear equation with the, instead of equal, it's approximately, so we can find out the equation. And also to see at the statistics section, we can see like how well it fits. So this is like 99%. And so it says that, so M is the slope and B is the y-intercept. So the slope is 0.15. So it seems to be, the force is like increasing 15 force, while the percentage is like increasing 2 to 3%. So we can say that's 2.5 because 2 plus 3 is 5, and 5 divided by 2 is 2.5. And so that's the graph. Of course, you could have just done like rise over the run. I don't think it's A because compression is not doubling. 9 times 2 is 11, 11 times 2 is 22. That's clearly not happening. It's not A. C and D is wrong because this graph is not exponential. And so it should be B. Alright, to properly view a Snellen eye chart, if the tallest letter is 88 millimeters tall, the person should stand 6 meters from the chart. The distance is proportional to the height of the tallest letter. How many meters from the chart should the person stand if the tallest letter is 45 milliliters tall? Round to the nearest hundredth of a meter. So basically, it's just proportions. We have the tallest letter is 88 here, and we have the person should stand 6 meters away from the chart. So we can make that equal to 45 millimeters is how tall the tallest letter is, and then we can use these two fractions to find out how many meters away the person should stand. So we multiply these two and then divide it by 88. So 45 times 6 is equal to 270 divided by 88. It should be around 3, and it says round to the nearest hundredth of a meter. So it should be 3.3 3.07. Nearest hundredth and 6/8 rounds to 7. 3.07. 3.07. Eddie will enter high school next year. His older brother tells him that everyone in high school plays a musical instrument. Skeptical, Eddie decides to investigate. Throughout the next month, he asks a randomly selected sample of high school students whether they play an instrument. The table shows what Eddie finds. Rounded to the nearest percent, what percentage of all 10th graders do not play an instrument? So we're looking at 10th graders only. And it says what percentage of all the 10th graders do not play an instrument. So that means that the total that we're looking for is only all the 10th graders. Okay, so let's circle what we're looking at here. So we're only looking at the 10th grade column. And the first row is plays an instrument. The second row does not play an instrument. So this number is important. This number is important too, but we're just adding that to the total. It shows the total here for us. That's 25. So our percent should be 22 over 25. And we can put that into the calculator to see what that gives us. But if, as we can see, 25 is a factor of 100. So just multiply that by 4. That's going to give us 88 over 100. And so it should be 88%. But put that into the calculator. 22 over 25 is 0.88. So that means 88%. So the percentage of all 10th graders that don't play an instrument, it should be 88%. It's telling us all 10th graders. So the data of 9th grade, 11th grade, and 12th grade won't matter here. A student answers 86 problems correctly, which was 81.9% of the total number of problems on the test. How many problems did the student answer incorrectly? So we don't know the total number of problems, which is what we're trying to figure out, and then total minus 86. And we need to make sure that the 81.9% of the total number is going to give us 86. So we can use the open technique, or the open technique for this problem here. So when we spell out open, that's open, right? It stands for original. This is original times percent equal to, so E stands for equal to the new one. So we don't know the original, which is the number of total problems. So we can say it's X times the percent. X multiplied times the percent is 81.9. So we're going to give it 0.81.9 is equal to the new number, which is 86. And so what we do here is just divide both sides by 0.819. And so when we do that on the calculator, 86 divided by 0.819, that's going to give us 105. So 105 is the total number. 105 is the original number. But it's asking us how many problems did the student answer incorrectly. So 105 is not how many he answered incorrectly. We know that he answered 86 problems correctly. So we minus 105 minus 86, and that's going to give us 19. So it should be B. Emmanuel surveyed a random sample of 50 subscribers to Auto Wheel magazine about the number of cars that they own. Of the subscribers surveyed, 15 own fewer than 2 vehicles. There are 340 subscribers to Auto Wheel magazine. Based on the data, what is the most reasonable estimate for the number of Auto Wheel magazine subscribers who own fewer than 2 vehicles? So Emmanuel surveyed sample of 50 subscribers to Auto Wheel, but there are a total of 340 subscribers. And so we know that of the 50 subscribers he surveyed, 15 own fewer than 2. So we want to know, out of all 340 subscribers, how many would own fewer than 2. So this is a proportions question, so we can set up a proportion or ratio. We can put the total at the bottom. But when we make sure that when we do these proportions, the same set of data is on the denominator, and the same is on the numerator. So for this one, the total is the denominator, and at the top is the amount, or the numerator is the number of people who own fewer than 2 vehicles. So that would be 15 up here. The total is, we have 340, and then this is x. That's what we're trying to solve for. And so we can do that in the calculator. 340 times 15. That gives us 5,100. 5,100 divided by 50. That gives us 102. So the most reasonable estimate is 102 out of the 340. Okay, we have a scatter plot here of online course enrollment. The scatter plot shows the number of college students in lowercase n in millions who enrolled in at least one online course from 2002 to 2011, where T represents years since 2002. A best fit lineup approximates the data is also shown on the scatter plot. Which of the following is closest to the yearly increase in online college student enrollment from 2002 to 2011? So we're trying to find the approximate yearly increase in online college student enrollment from 2002 to 2011. So right here is 2002, and this is 2011. 9 years after 2002 is 2011. So at 2002, number of students enrolled was around 1.45 million. Well, actually, I'm looking on the line of best fit, but here it actually shows that dot right there is like, so we're looking for a yearly increase. So each year, like the average of each year, or the average of all the years of each year. 2003 had 2 million, so that's like a 0.5 million increase, 500K. And then let's see, the next year was another 0.5, so it seems like kind of 0.5 each time. 500K is definitely not A. It can't be 130,000. That's just like way too little for all of this. There's no way it can be D. 58 million 58 million isn't even on this graph. And then 1.7 million is not gonna be the answer either. And so out of these choices, the most reasonable one is gonna be B. For each of the 15 countries in the Middle East, the percentage of the labor force in agriculture was recorded to the nearest 5%. This data is shown in the dot plot. Based on the shape of the data, which of the following correctly compares the mean and the median? So all we have to do with this data, we need to find the mean and the median. So we can write down the median real quick. So we have 0, 0, 5, 5, 5, 5. Very quick way to do this. Obviously, you don't have to do this on the SAT. You just do really quick. So I would count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15. So around number 8. And then we can count each side. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there's 7 on each side. So this dot right here is the median. And that would be 15. So 15 is the median. We can check with this. So 1, 2, 3, 4, 5, 6, 7. This one right here is the median. 1, 2, 3, 4, 5, 6, 7. So 7 on each side. And then the mean, we'd have to add everything up, divided by the number. So that's going to give us 330. I didn't add the 0 because there's no point, but make sure to count those zeros. So in total, we had 15 from what we counted earlier. So the mean is 22, and the median is 15. And so then the mean is greater than the median. A supernova burst is monitored by a telescope over the entire spectrum. The graph in the TP plane shows the power in capital P in nanowatts, which is NW, captured in the visible spectrum t seconds after the start of the burst. What is the significance of the point marked on the t-axis? So they're asking us what this right here means. So based on what we're given, what we see on the graph, the y-axis is the power and the x-axis is the time. So the power started to increase at 1.3 seconds. So yeah, that point indicates when the power started. So when the nanowatts started to burst. So let's see what choice says that here. So A, the point indicates the start of the supernova burst. The point indicates the length of time of the supernova. I don't think so, so that's wrong. The point indicates the time when power was at a maximum. No, that is wrong because clearly that's not where the power maxed out. It should be here. So C is wrong. And then D, the point indicates the time when power began to be captured in the visible spectrum. I believe D is correct because here is telling us that the graph is showing the power captured in the visible spectrum t seconds after the start of the burst. So if we're saying 2 seconds after the start of the burst, that means the start of the burst already started back over here. If we're saying 3 seconds after the start of the burst, the power is at 7. That means this point indicates when the power became visible. So it should be D. Okay. A shipping route from Los Angeles to Honolulu is 1,946 nautical miles long. Approximately how long is the route in miles? So 1 nautical mile is 1.15 miles. So all we have to do is multiply this by 1.15. 1,946 times 1.15. That gives us 2,237.9, which rounds up to 38. So 2,238 miles long. Here it shows some of the work here. Yeah, all you have to do is just multiply that. I think setting up this fraction takes up too much time, but you could do that if it helps you understand more. But yeah, that was Unit 7 of Problem Solving and Data Analysis Medium, and I hope that helped you. And thank you so much for watching, and good luck on that test.